left hand limit. LHL. This is LHL. We can find as just few seconds. Remember always whenever they'll give you like LHL is limit x tends to a, whatever we have here, and we will take for LHL here minus sign. Fx
Yes, ma'am.
is equal to, we write it as limit h tends to 0 f a minus h. Means in a state of x, we put x is equal to a minus h for LHL. And for RHL, limit x tends to a positive. If they'll not ask you, this positive sign represent RHL and this negative sign represent LHL. Because on number
Okay.
line, you can see here on left side, we have negative number. On right side, we have positive. Okay.
Yes, ma'am.
So this, we can find fx is equal to limit h tends to 0 f a plus h. Okay.
Yes,
A
ma'am.
plus h. So now let us do that. Let us find for second question. Here we have function fx is equal to 1 if x is less than 1. Fx is equal to 2 minus x if x is greater than 1 and less than 2. Okay.
Okay, ma'am.
And 2 is equal to when x is greater than or equal to 2. And at x is equal to 1. Yes, at x is equal to 1 and 2. Okay, this is different question. Below is different question. Okay, okay. Discuss the existence of the limit of the function f defined as if for existence of limit, what we have condition means for existence of limit, it should be like LHL must be equal to RHL. Okay.
Okay, ma'am. Yes, ma'am.
Okay, I'm telling you. Limit of the function exists when LHL is equal to RHL. Okay. So let us find now. See, for LHL, we take this fx because for less than 1, we have fixed value 1. And for greater than 1, we have, sorry, greater than or equal to 2, we have 2. So now we have fx in question given that fx is equal to 2 minus x. Why? Here value of x lie between 1 and 2. Okay.
Yes, ma'am.
So let us find, because other values are constant. So let us find limit. Let us find both limits. Okay.
Yes,
Limit
ma'am.
x tends to a. Sorry, x tends to 1. Why? Because it is greater than 1. Okay, because the limit of this function lie between 1 and 2 here. So let us take 1. Fx.
Ma'am,
And
after
for,
it, so we take 2 as well there.
yes, ask.
We will take 2 as well now.
Yes, we can take 2
Okay,
as well. Okay. In
okay,
both
ma'am.
way we can find. If you take
Okay,
uh, x tends to 1, then for RHL you will must take x tends to 1 only. Okay. And if you
okay,
are
ma'am.
taking 2, then you can take this 2 for both limits. Okay. Are you getting me?
Yes, ma'am, I'm getting.
Minus. Minus sign represent LHL. Is equal to limit h tends to 0. F. Here A is 1. Okay. A is here 1. So 1 minus h. Got it?
Yes, ma'am.
So when wherever we have x, in a state of x, we will put 1 minus h. Are you getting me?
1 minus h.
Okay. In a state of x, because here we have x, and here we are taking, in a state of x, we are taking 1 minus x, 1 minus h.
Yes,
Okay.
ma'am.
So let us put everywhere where we have x, you will put here 2 minus 2 minus, in a state of x, we will put here 1 minus h.
Yes, ma'am.
Okay. So now we will have limit h tends to 0. 2 minus 1 plus h. So now let us put value of h. So 2 minus 1 is 1 and plus 0, it is 1. Now
Yes, sir.
let us find RHL. Okay, now let us find RHL. Limit x tends to 1 positive fx is equal to limit h tends to 0 f a plus x, a plus h, sorry. So let us find limit h tends to 0. In a state of x, we put a plus h means 1 plus h is equal to limit h tends to 0, 2 minus 1 minus h. Are you getting me?
Yes, ma'am,
Because
I'm
when we
getting.
open the bracket, obviously we will get both value negative. So 2 minus
Yes,
1 is 1
yes,
and
ma'am.
minus 0. So it is 1. And we will explain now, since LHL is equal to RHL, hence limit exists. Because both limits are same, that is why we can conclude limit exists. Okay?
Yes.
Since LHL is equal to RHL, hence limit exists. Got it?
Yes, ma'am, I got it.
Okay, you send me next questions, okay? So here you need to find direct like by applying direct limits. Okay, so let's do it. Which question you want to ask? 16th.
Yes, ma'am. 16.
Okay. So first question based on direct formula.
Yes, ma'am.
Okay, we have done yesterday. Log EA, remember? Limits formula.
Yes, ma'am. Log EA. You tell.
EA, yes. Now let us do next questions.
Ma'am, I'm talking about the question 9 of first. You tell me yesterday. The expansion question.
Okay, expansion question. Have you taken screenshots?
Ma'am, let me check. I also have the white page you have shared me in my Gmail. Ma'am, I had sent you the ninth question.
So you didn't get that question?
Yes, ma'am, I didn't get. Can you also tell me the formula of that?
See,
Ma'am, I didn't.
you need to know first of all factorial value.
Yes, ma'am,
Okay?
you tell me the factorial value.
Yeah, I told you yesterday about factorial value also.
Yes, ma'am, I know factorials.
this is symbol, exclamation mark is symbol. Factorial 0 is equal to 1. Factorial 1 is equal to 1. Factorial 2, you can find 2 into 1 is equal to 2. Factorial 3, you can find 3 into 2 into 1, that means 6. Similarly, you can find factorial value for any other value, like factorial 4 is 4 into 3 into 2 into 1. This is
Yes,
24.
ma'am.
Now let us understand this expansion. This is said to be binomial expansion.
Okay, ma'am.
Binomial expansion is when we have 1 plus x to the power n, it is equal to 1 plus n into x plus n into n minus 1 into x square by factorial 2 and plus up to so on. Plus up to so on. This is formula.
Yes, ma'am.
Okay. So now let us do this ninth question. Limit x tends to 0, 1 plus x to the power n minus 1 over x. Now let us put value of this expansion. This is this all. So you use on phone, are you taking class on phone or on laptop?
I'm in laptop.
Okay, so from the next session, you can record this session on your side also, okay? You can send me
Okay,
permission to record this lecture, okay?
okay, ma'am.
Yeah. Limit so that you can revise whenever you need. And now let us put value of this expansion, this entire, okay? Let us put here.
Yes, ma'am.
1 plus nx plus n into n minus 1 into x square by factorial 2. Minus plus up to so on and minus 1 upon x. We can cancel this plus 1 and minus 1.
Yes, ma'am.
Limit x tends to 0 and we have n into x plus n into n minus 1 into x square plus up to so on over x. Now we can take x as a common because we have x in each term. So let us take common so that we can cancel x which is in denominator. X and inside we
Ma'am,
have n plus
factorial 2.
n into n minus 1 into x and by
Ma'am,
factorial also.
yes, ma'am. I tell all this.
Yes, factorial 2 and plus up to so on.
Yes, ma'am.
Now we can put the value of x. So we will have because this term is not having x and plus n into n minus 1 into 0 plus and up to so on. So we will have n as answer.
Yes, ma'am.
Okay.
And now
This
I
is
got it.
this. See the third question. Let fx is equal to x and 3 minus x when x is greater than or equal to 0 and less than or equal to 1. And 3 minus x when x is greater than or equal to 1 and less than or equal to 2. And they are
Ma'am.
asking, see, in above question, we found here for like x is equal to 1. Okay, above question we have done
Yeah.
for x is equal to 1, and you need to do for x is like x tends to 2 also. See, they have given
Yes.
to us at x is equal to 1 and at x is equal to 2. Got it?
Yes, ma'am. Yes, ma'am.
Yes. So now I'm telling you this. Here x is greater than or equal to 0 and less than equal to 1. Then fx is x, and when it is greater than 1, greater than or equal to 1, and then less than or equal to 2. Okay. So they are saying that f1 plus 0 is equal to 0. Does the limit of fx at 1 exist? Give reason. Okay. At 1. So we will take 3 minus x. Okay. We will take this function because here x is greater than or equal to 1. So here we have
Ma'am, I
equal to
don't
1.
see your writing.
Are you getting me?
Ma'am, I didn't able to see where you write.
I didn't write anything. Okay. I'm explaining just you. See the
Okay,
third
ma'am.
question.
Yes, ma'am.
They are asking, what does the limit of fx like at x is equal to 1. So we will take function fx is equal to 3 minus x, because here we have x is greater than or equal to 1. Greater than or
Okay.
equal to 1. So obviously we will take this. Okay. So let us
Okay, ma'am.
find here LHL and RHL.
Yes, ma'am.
So LHL, limit x tends to 1 negative fx, and this is equal to limit h tends to 0 and 1 minus h. Wherever we have fx, and here write the fx. Here fx is equal to 3 minus x. Okay. So in a seat of x, just put 1 minus h. So limit s tends to 0, 3 minus 1 minus h. Limit s tends to 0, 3 minus 1 plus h.
Yes, ma'am.
Oh, I think I made a mistake. Yeah. Sorry. Maybe I made a in before this. Before it, yeah. Yes, sure. Not an issue. Sorry, I forgot that. Because sign of H only will change. Nothing will change, only sign of H will change in left and right. Okay. So we have limit H tends to 0. 3 minus 1 is 2.
Yes, ma'am.
2 plus H. Now let us put value of H. That is 0. So LHL is 2.
Yes, ma'am.
Now let us find RHL. So RHL. This is limit x tends to 1 positive fx is equal to limit x tends to 1, or yes, we are finding in terms of h, so we can write here s tends to 0 and f 1 plus h. Whatever we have here value, we will take together with this h. Okay.
Ma'am.
Limit h tends to 0, 3 minus 1 plus h. So we will have limit h tends to 0, 3 minus 1 minus h. Now let us put value of h, 3 minus 1 is 2, and value of h is 0. So we have RHL is 2.
Yes, ma'am.
Hence, LHL is equal to RHL. Okay. You got now?
Yes, ma'am. Now I got it.
Okay. And if in next session, first of all, I'll tell you types of function because you are facing because of you don't remember types of function. So first of
Yes,
all,
ma'am.
I'll tell you because next question need types of question like signum function, floor function, ceiling function like that. That is
Okay,
why.
ma'am.
Okay. And meanwhile,
Okay,
you
ma'am.
can send me from the beginning, like from where your chapter start, because I want to see which types of questions, like uh, because we have lots of formulas, okay? But I want to see which formulas they are using, okay?
Okay, ma'am.
So
I will send
including
you.
example and formula, send me entire chapter.
Okay, ma'am. I will send you entire chapter.
Yeah, yeah. I'm waiting. You can send me, and we will do the next in next session, okay?
Okay, ma'am.
So that I can prepare notes for you accordingly if we need. Okay. Yeah.
Okay, ma'am.